Like I said, your actions contribute to the success or not of everyone around you. Okay, so I need you to be able to add and subtract with numbers in scientific notation or standard form. Okay. Once we've done that, move. So something like, should we say 7.3 times 10 to the power of 6 plus 5.1 times 10 to the power of 4. Okay, that's a kind of example of something you want to do. Thumbs up for yes, thumbs down for no, middling, I could give it a go. But... Answer in standard form or in scientific notation, please. I'll pause them. Okay, so without calling out names, quite a few of you went down the track of, well, I've been doing laws of exponents. I'm just going to do laws of exponents, even if they don't really meet the requirements for those laws of exponents. Like, what have I done? Oh, I've added exponents before, so I'm just going to do that. Charlie already told us why we don't add any exponents. The law of adding exponents is only when you multiply. Right? If you multiply those things together. So for instance, if I've got 10 to the power of 6 times 10 to the power of 4, that would be 10 to the power of 10. But I don't have that, I have add. Okay? If it was subtract, it would be 10 to the power of 6 divided by 10 to the power of 4, which would be 10 to the power of 2. If it was multiply, it would be 10 to the power of 6 to the power of 4, which would be 10 to the power of 20. None of these are in that. So, we've never divided exponents. Remember, sorry, I'm cutting people off. Remember why we're allowed to add
the laws of exponents.
But where did that come from?
Of the amount of the places that we should
No.
the laws of exponents.
But why can we add the exponents?
The base.
Because you have the same base. And you're just repeating the multiplication. Yeah? Not quite. Anyway, guys, the reason why we add the exponents is because basically we have 10 times 10 times so on, but then this times goes in the middle, and we can't actually differentiate where the times is. That's very different to 10 times 10 times 10 plus 10 times 10 times, and so on, yeah? The plus is very easy to spot. Now, when it's only multiplication, well, if I've got 6 of them and 4 of them, I might as well just have 10 of them in a row. Yeah. Why the divide? Well, I was just explaining that again to Gabby. When you divide after multiplying, it cancels it out, right? So you basically remove one of the multiplications by dividing. Removal is like subtraction. Times by what? Okay. No, we don't divide. I'm not saying that. These are your laws of exponents. So I am not adding things with exponents. I'm not multiplying things with exponents. I'm not dividing things. The laws of exponents don't apply when we're adding and subtracting. What is important, though, is to take consideration of the place value of the numbers you have. Okay? Remember I said yesterday, so like fractions. You can't add thirds and fifths. They're different, right? That's 7. Oh, it's not a 7. No. What is that 7? It's 7, but in the times 10 to the power of 6 column, which is
700,000.
700. That's not a 7, that's a 700,000. So the only thing you can add to a something in a 100,000 column is another 100,000. Does any of these, is it 100,000? No. So Isa did mention that do we need to write it in normal form first? We can, and I'm going to do it to explain it, but we don't necessarily need to do that in the future. Sorry, Axel, what were you saying?
The formula record.
Well, let's have a look. I'm losing you again. So, 7 point, the bit of practice, we're going to do 7 times 10 once, twice, 3 times, 4 times, 5 times, 6 times. So it is actually, you're right, 7,300,000. Part of the problem in some people's criterion B was that it was just counting zeros. So that number is 7.3 million. This number, right, is 5.1 times 10 to the power 4. So I'm going to write it 5 times 10 once, twice, 3 times, 4. So the 5 is actually in the 50,000 column, and the 1 follows, and then 0. So those two numbers, when you add them together, actually is only 75100, which is what in scientific notation? 7 times 10 to the power 6. Okay? Now, makes sense. Does anyone spot a quicker way than having to rewrite it? Or both? Ben?
One decimal place in 7.3 times 10 to the power 6, and 10 to the power of 4 is 2 exponents less than 10 to the power 6. You can just do 7.251 10 to the power 6.
Yep, that's one way of interpreting it. Aaron?
I don't really know how to explain it, but you look at the difference between the powers of 10
Yeah.
and then you put the decimal.
I think you're doing like Ben was, you're kind of slotting it into the spots that you visually. I'm kind of like that as well.
This computer property, so like 7.3 times 10 to the power 6 is 5.1 times 10 to the power 4. They just have the common factor of 10 to the power 4. I can take that out. But then I have 10 to the power 4 times bracket 730 plus 5.1.
Try it again, try it again. Didn't hear that?
Is a nice, good, high level maths way of thinking. Are you all gonna pay attention? Because everyone just kind of switched off and haven't started talking. Yeah, you were. Okay. I think what he said was a perfectly reasonable way to say it. I think maybe some of you aren't ready for it. Okay. So before we go, because we haven't necessarily talked the distributive property, let's just look at kind of a way of looking at. Let's look at a way of thinking about how we can just add them. Ways. Remember I said about fractions, Eta? We can't add fractions together unless we find a common denominator. So what we could do is think about writing them in the same value system. All right? So they both have the same times 10 to the power of something. So for instance, I'm going to leave the first one, but I'm going to rewrite this number as something times 10 to the power of 6 to make this the same as that. Then the number I have, everything is matching up value-wise. Okay, does that make sense? Yeah? So how can I go from 5.1, this is a tricky, that's why it's a level 5 to 6. How do I get from 5.1 times 10 to the 4 to something else that needs to be times by 10 two more times? Okay, so let me say that again. I know some of you are like on this straight away because that's how you did your criterion B. Some of you didn't, so this is going to be slightly new to you. Lots of people think of this as, well, I'm at 5.1, but 5.1 is a number that was divided by 10 4 times. So that then I have to multiply it by 10 4 times to get back to where I was. That's what some people wrote, yeah? So if I need it times 10 to the power of 6, I need to know what number, if I times it by 10 6 times, will get me to the same number as this one times 4. So, if I've got to times this by 10 2 more times, what do I have to do to this number?
Divided by 10 to the power 2.
Divide it by 10
10 to the power
2 times first. So that's going to be 0.051. That number times by 10 6 times will get me to the same value as 5.1 times 10 only 4 times. Now, here's the reason why that's useful, is because now I've got the 7 and the 3 are the same value as the 0.1. Whatever that answer is, I just need to times it by 10 to the power of 6. Yeah?
Why don't we put it in expand? Then we have to.
Okay? Now, just a question that I'm likely to get. Does it matter if I change the 10 to the power of 4 into 10 to the power of 6? Or should I change the 10 to the power of 6 into 10 to the power of 4? Does it matter which way I want to do?
It doesn't matter. No, because you can just change it back into.
Good. There's the answer. Not really, but if I changed it to 10 to the power of 4, I would have an answer that needed to be changed to scientific notation in the end. There'd be one more step.
It's better to change the smaller number into the bigger number.
So you want to, well, even then, when we add together, we might end up with something that still needs to be done. But yes, we focus on. Should I give you another one to try? Yeah. This time I'm going to give you subtraction.
Is that no? It's the same.
Same thing. Only instead of adding, you subtract. So let's go for 4.7 times 10 to the 3 minus 1.6 times 10 to the power of 5. It's going to be interesting. Okay. Let me ask that. Which one did we change? First one, let's change this. So I'm going to make that. Again, you could write it all out. You could write it all out. I'm just going to make it times 10 to the 5, which means this number here, I'm going to talk it through all the time because it's what I do in my head. Things don't come naturally to me, just like it might not come naturally to you. 4.7 needs to be multiplied by 10 3 times to give it its true value. If I want to make it times 10 5 times, that means each number has to be multiplied 10 another 2 times to give it the same thing. So we're going to end up with 0.047. Yeah. And then we're going to subtract 1.6 times 10 to the power of 5. So now we've got 0.047 subtract 1.600, and whatever answer is times 10 to the power of 5. Go.
I thought easier to do was do 1.600 subtract 0.607 and then break it negative.
It is easier. Everyone, we've got some interesting talking points, and it's good to have these discussions because what Charlie's just mentioned there is more like a real deeper understanding of what I'm doing and what I can use to make my maths efficient. So I'm going to do it this way round because I saw a number of you were ending up with positive answers. Okay, now, why did Charlie say it's actually easier to do it the other way and making it negative? Well, because if I do this, well, how do we do it? What written method have we got? So 7 subtract 0. 7. 4 subtract 0. 4. 0 subtract 6.
Negative 1 6.
It's 0 subtract 6 is negative 6. But do you want me to write negative 6? And then 0 take 1 is negative 1. Okay, well, I think that's where this understanding comes from. That is what we need to do. Now, I can look at that and say, I know it's going to be a negative number. So, as Charlie correctly says, I know it's going to be negative. I can just subtract them the other way around and my answer will be negative, not positive. Negative numbers on the number line are the opposites of their positive character, right? So as long as we understand that, we're good. So let's do 1.600, take away the 0.07. Now we've got 5 carried 1, that would be a 9 carried 1. 10 take away 7, 3. 9 take away 4, 5. 5 take away 0, 5, and 1. So I've got 1.553, but we know it should be negative, not positive, times 10 to the power 5.
So how do we know? That's that way.
Sorry, ladies and gentlemen, again, I've had a question. I know I have already answered this a few times. Okay? The reason why she hasn't picked up on it. When I'm talking and saying these important things, you're all off having your own little discussions, which may be good discussions, but you're missing things. Is there anyone that would like to tell me how, when I looked at the question originally, I know it's going to be a negative answer?
Yeah, I get it now. Small number.
Small number minus big, as simple as that. So I know it's going to be a negative.
But if it was 100.
Okay. That's it. That's adding and subtracting. Now, just as a note though, if you're allowed your calculator in an assessment,
Use it.
could just use it and get the answer, right? What do you think? Are you going to get any credit for that? I will, even though it's only a criterion A, need to see evidence of this.
Yeah, I figured it.
I need, because criterion A is about skills and knowledge. Knowledge and understanding, knowing and understanding. So if you just chuck it into your calculator and write an answer down, how much knowledge and understanding have you provided evidence that you have? None. Yeah? You know how to type in it, which is some, little bit.
You know what the signs
It shows that you know the formula.
Well, it doesn't actually. It knows you can type in the stuff in the order, because the calculator will even do it in the correct order for you, because it will do multiplications before it does subtraction, because it follows BEDMAS. So there's not even that. Sometimes you can get it wrong because your calculator doesn't do it for you. So I will expect to see some form of you showing understanding. I would expect to see you. Now, I am perfectly happy, if you wish, to do that. No problem. Well, what I would say is in that book that I gave you, you've got some questions dotted in there that has addition and subtraction in there, right? That booklet of GCSE questions. You should be able to find them. Yeah. Charlie.